you are going to have to be able to factor these quadratics in order to do these problems. So, if you're not sure, just take a guess what numbers you think you might need, okay? So I have no idea, so I'm gonna say 5 and 1. And since that's a negative, thinking in my head, that's a negative, I know that when I FOIL this out, regular FOIL it out, this times this has to give me that number. Last times last is gonna give me that number. And since that's a negative 5, don't I need something to be positive and something to be negative? Yeah. Okay, now I FOIL. And it didn't come out right because these add up to a plus 4x. And what do I need it to be? A minus 4x. So I'm good, except my sign is wrong. So I'm just gonna change these, make that a minus and that a plus. And will that fix it for me? Yes. Now what I'm trying to tell you guys is this. You factored when you were freshmen. You factored when you were sophomores, and you spent a lot of time last year factoring. I am not going to teach you to factor. You've had many opportunities. Now it's on you. And the good news is, you'll always know whether you're right or not because you can always FOIL it to check it. If you don't take the time to FOIL it to check your work, I don't have any sympathy, right? That's what we do. That's what I do. I never factor without FOIL to check it. That's what you need to do. All right, so we got this one factored. Okay, anybody get this guy factored? You think you got this one factored? X and X, of course, and then what? What'd you come up with here?
Plus 10 minus 1.
Plus 10 minus 1, and that looks good to me because I'm FOILing and I see a negative 1 and a positive 10. That's going to give me a positive 9. Perfect. How about this one?
Minus 5 plus 2.
Minus 5 plus 2. Let's do a quick check. Positive 2, negative 5 makes negative 3. Right on. This is a factor. Okay. Now, if these were equals, like they were last year, if that was an equal 0, you would just say x equals 5 and x equals negative 1. Remember that? It's always the opposite of what's in the parentheses. Always. Okay, remember that? Well, here's what I want you to do now, just like yesterday. I want you to draw a number line, and I want you to put 2 dots on the number line. The dots are going to be open, and guess where the dots are going to be? At negative 1 and 5. Now that is a number line, so make sure when you put your dots on that you have them in the right order. Okay, because that is a number line, so you got to go counting order. Okay, now I want you to think about what I said yesterday, if you can remember. I have 2 dots on the number line. Anytime I have 2 dots on the number line, and I have to shade, this is an inequality, I'm going to shade. I'm either going to do what? I'm going to shade in between them, or I'm going to shade outside of them. Okay, same rule. I got 2 dots on the number line. I'm going to shade in between them, or I'm going to shade out of them. Where am I going to shade in this problem? Do you remember? Look at the symbol. To greater than. Where do I shade greater than? Outside. So the answer to the problem is this section of the number line and this section of the number line. Then I have to write an answer. That's kind of like my work. I have to write an answer. So negative infinity to negative 1 is this side. Would you agree? Don't just stare at me blankly, guys. You got it? And then this side is going to be 5 to infinity. And then, since there's 2 pieces,
U.
put a U in between, and that U stands for union, and really means the word or. When I read this to someone, I would say this or this. Okay? Easy. All right, so this one. You already factored it, that's step one, you gotta get it factored. Then, 2 dots on the number line. This time, those dots will be closed. And where will they be? At -10 and 1. Everybody good with that? Opposite of what's in your factors. Is it important that you factor correctly? Yeah, because that's where your answers are coming from. Okay? Now, shade it. Where are you shading this time? Inside. No or, no use this time, just one chunk. -10 to 1. How do we feel about that?
Wait, why is it -10? Cause in there, it's 10.
Same reason that was
yeah,
right.
I see.
Remember, that, you know, we've done so many of these, most people at this point don't have to write this down anymore. But if you were solving this, you would say x plus 10 equals 0 and x minus 1 equals 0. Remember?
Yeah.
And so what happens when you move that 10 over?
-10.
Yeah,
Okay.
yeah. Every time it's the opposite. Okay, you already got this one factored. There's your number line. Here's your 2 dots. Where are these dots? -2 and 5, and put them in that order. On the number line, -2's over here and 5's over here. Where am I gonna shade?
Inside.
Inside. So my answer is that. These are easy, guys. They're easy if you can get them factored. Easy. So, there's another one, D. Problem D. I want you to do D, and then I want, with your partner or by yourself, and then I want somebody to come up and put D on the board for us. Problem D. We're in our notes. Okay. Come on, I need a volunteer, guys. Nobody can do this?
Sure.
Okay, thank you, Lauren. We're all kind of down in the dumps today. We need to liven up here. Before she gets too far into it, what do you think of her factoring? Is her factoring okay?
Yes.
+2 +3? And there's her check, I love it. So she's got it, perfect. on your number line that your numbers are like hers. -3 is farther that way, and -2 is on this side. Good job. She's using brackets, should she be? Yeah. Not for the infinities, but for the numbers, absolutely. I think she's got it. What do you think? Good with that? Guys, yeah?
Yeah.
Okay. Now let's look at the next problem, because now things are a little bit more complicated, because why? What's different about the next problem? There's a cube, okay? So with cubes, we don't do what we just did. I mean, we kinda do, but we can't factor it this way. What I want you to notice is, there's a GCF, isn't there? So we're gonna take that out first. So we're gonna take the X out first. So I took an X, my GCF, out of everything. And then I have this right here. Can I factor that the same way we've been factoring these other things?
Yeah.
Yeah, so the X is there. Don't lose it, you gotta keep it. The X is there. But now I'm gonna take this part and break it down into two factors. Anybody have a wild guess? At least the first stab at it. Let's just take a stab at it. What do you think these might be?
2 and -4.
What?
2 and -4.
So +2 minus 4? Let's check it and see. X squared minus 4x plus 2x minus 8. I just FOILed. Does that work out to be what I want it to be, -2?
Yes.
Absolutely. I'm good. Perfect. Now, here are the factors. There are 3 of them this time. There's these 2, and then there's that X that I pulled out. That means on the number line, there will be 3 dots. Okay, now the rules are changing. Now I have 3 dots. Would you agree I'm gonna have a dot at -2
Yeah.
and a dot at 4?
Yeah.
Where is that dot gonna be?
1.
No,
0.
0. 1 would look like this, wouldn't it? If there's no number hooked to it, the dot's gonna be at 0. So one of my dots is at 0, one of them's at -2, and one of them's at 4. 3 dots. All open. And now I have to shade. Now, when there's just 2 dots, it's easy. Inside, outside. When there's 3 dots, you have to do 3 or more. You have to do a little bit of extra work, but not a lot. Here are my factors. I want you to pick any number on this number line except a dot. Don't pick a dot number, pick any other number on the
1.
number line. 1. She picked 1. The number 1 is right here. Would you agree? If I were gonna put a dot, it would be in here?
Yeah.
Okay. Now, I want you to go back to your problem, and I want you to put a 1 in for all of the X's. Now, I like to do it in my factors, but if you want to go back to the beginning problem, you absolutely can. It doesn't make any difference. I'm going to plug 1 in, so I get 1 times 3 times -3. So I put 1 in here, and I got 1 plus 2, that's 3. And then I got 1 minus 4, that's -3. These are all multiplied together. If I multiply them together, guys, 1 times 3 times -3, do I get a number bigger than 0? No. That means that wherever 1 was on the number line didn't work, so I don't shade it. So this is not shaded. Because when I tried a number in that section, it did not give me a greater than 0. It gave me -9. Okay? Now, the bad news is you have to do that. The good news is, once you've done that, there's a shortcut then. It turns out that every other section of the number line, so you have this section, this section, this section, this section, every other section is shaded. As soon as you figured out that this section is not shaded, then what does that mean? This one is, and this one is, and this one isn't. Every other section is shaded, or not shaded. So the minute we knew that one wasn't shaded, and we had to figure that out, and we figured it out by plugging a number in. As soon as we figured out that one wasn't shaded, then I knew this one and this one had to be. Every other one. Okay? So here comes my answer. -2 to 0, that's that section right there. Or 4 to infinity. Are you ready to try F? What are we gonna do with F?
Okay.
You don't
Take an
know.
X out.
Take an X out.
Yeah.
When in doubt, Jake, look at what we did on the previous problem over here. So we're gonna take an X out. And what are we left with when we take an X out?
X squared minus 1.
Oh,
Oh no.
does X squared minus 1 ring any bells for you? You have to factor that. That has to be factored. Looks a little different, but it's a special factoring. Does anybody remember? Difference of squares. And how does the difference of squares factor?
Not good.
Oh no, it's easy.
1 plus,
So you do.
What?
is it 1 plus and 1 minus?
Exactly. So it's gonna be X minus 1 and X plus 1, the order doesn't matter. So just to refresh your memories, what would X squared minus 9 be?
X plus 9, X minus
No,
3.
not 9, X plus 3, X minus 3?
Yeah.
And what would X squared minus 25 be?
X plus 5.
Yeah.
X minus
Yeah.
1.
So X squared minus 1 is X plus 1, X minus 1. This is called the difference of squares. And that's how it factors. Okay, so here's my number line. I've got 1, 2, 3 dots on the number line. There's 3 X's, kids, in the problem. Every X gets a dot.
Aren't the dots supposed to be
The
filled in?
dots are gonna be filled in.
Mm.
And where are the dots gonna be?
-1 plus 1. No,
Negative
0.
1, positive 1, and 0.
Yes.
And of course, I have to have them in the right order on the number line.
Yeah.
Okay. Now what do?
You find a number.
A number.
Yeah.
Any number that's not a dot. Now, let me just give you a little hint.
Wait.
I don't think I'm gonna pick a number in here because wouldn't it have to be a fraction? And you guys don't like fractions. I'm not gonna pick a number in here.
No.
No,
Let's
why don't I
pick
pick a
number
number?
2.
Like 2, right? Let's make life easy. We'll pick 2. 2 is right here. This is the area that I am checking. 2 is not a dot. I am just checking the area where 2 is. So when I put 2 in, I get 2. 2 minus 1 is 1. And 2 plus 1 is 3. put 2 in right here. Or you can put 2 in up here, it doesn't matter to me. Put 2 in somewhere. If I put a 2 in here, I get 2 times 1 times 3. Is that answer less than 0? What does that mean? You don't shade that spot. If it works, you shade it. If it doesn't work, you don't. This is that area out here. So, if I'm not shading this section, then I will be shading this one, and I won't, and I will. When you test your number, you pick 2. It's either gonna work or it's not gonna work. If it works, you shade it where it is. If it doesn't work, you don't. And then every other section is shaded. So we got, this is not shaded. So shaded, not shaded, shaded. Sutton?
So, like, since we picked 2 for this one, you
Say
plug,
what?
since we picked 2
Yep.
for this one, you plug the 2 into all the X's?
Yep.
Okay.
And I do it in the factors because sometimes with the cubes and whatever, the numbers get really big, but it doesn't matter. You can plug it in up here if you want.
Okay.
Somewhere plug it in for all the X's. And then you have to see, is the answer I get less than 0? And if you put 2 in, it is not less than 0. So I did not shade
Wait,
it.
how'd you figure that?
Huh?
How'd you figure like it was less than 0?
Is 6 less than 0? There you go. Yeah.
Sorry, I just like.
So why are you filled in the 0 and the 1, and then the -1 and the negative infinity, whatever, but -1 and 0 isn't shaded? Like why?
Okay, so Vaughn, the 3 dots separate the number line into pieces.
Okay.
Pieces of shading alternate back and forth. I figured out by testing 2 that this does not work.
Okay.
So it is not shaded. That means this section is shaded because they alternate.
So it's like every other. Okay.
Yeah.
Okay.
The cheat code she said.
Yeah. Now, if you don't want to do that one, then you're going to check a number here, you're going to pick a number here, you're going to pick a number here, you're going to pick a number here. You're going to try each region. That's going to take forever, but it will also work.
Okay.
And it has to be less than 0?
If you're going to shade it, the answer has to come out less than 0. And when I plugged in 2, I got 2 times 1 times 3, which is 6. 6 is not less than 0. So that section isn't shaded.
Can we do a practice problem?
We got a couple more things we need to do.
Okay.
We just done 2 practice problems. Okay?
Yeah.
Now, I haven't written my answer yet though, so that's what I need to do. 2 parts. So I'm gonna say negative infinity to -1, or 0 to 1. And that will be my final answer. Okay?
But yeah.
Now, I need you to get your calculators out. Because now we're gonna do a little word problem.
Yeah, but
I don't know what one is.
Hey guys, we need to stay focused. We're gonna have time to do some more practice here. This formula, this is called the projectile motion formula. You are not required to memorize it. I will give it to you. However, you do have to know what all of these things all those weird letters and whatever stand for, okay? T, wanna take a guess what T is?
Time.
Time. So T, every T is time in seconds. Seconds. Okay? This guy right here is the initial velocity. Velocity and speed are not exactly the same thing, but for us, you can think of them as the same. How fast you're throwing the ball. How fast are you kicking the ball. This guy, which is called S sub naught, S sub 0, S sub naught, that is the initial height of the object, and it is in feet. There is a projectile motion formula for meters, but it has a different number out here in front. We're gonna do the feet one. So this is, okay, so pretend I'm gonna throw a football, okay? So here's the ball right now. So the initial height would be about 5 feet, because the ball's about 5 feet off the ground. That would be 5. If I'm kicking the ball from the ground, then the initial height would be 0, because the ball is on the ground. If I go out and stand on the building and drop something off the building, the initial height will be however tall the building is. Okay, that's the number that goes there. And then this guy is the height after t seconds. So this is where the ball starts. I have thrown it, or done something to it, kicked it, whatever I've done. And then after a while, I want to know, okay, how high is it now? This is that. This is the ending height. All right, now let's read the problem and see if we can figure out what's going on. A ball is thrown off of the top of a building 12 feet tall with an initial velocity of 18 feet per second. Okay, let's write our equation. Our equation is going to be that right there, but you're going to plug a number in here and you're going to plug a number in here. So we're going to have S of t, and if you want, you don't have to use that notation. You can call that h for height. You can call it y if you like to have just your equations y equals. We're going to put this into our calculator. So we'll put it in as y equals. So if that's easier, you can. And then we'll have negative 16t squared always. Now plus what? What is my initial velocity? That goes here. My initial velocity is what? 18. There's a t hooked to that, so it's 18t. Plus my initial height, which is what? 12. Okay, so this is the equation for this particular problem. This is the overall equation, but this is the one for this particular problem. You okay with that?
Yeah.
Okay, let's put that in on our calculator, because we're going to use our calculator to help us solve these. So put that in as y equals. Now, if the t bothers you, don't let it. That's like x, right?
Oh yeah.
That's like x.
So
So we're just going to plug in x. Negative 16 x squared. By the way, this is a negative, not a minus. Where do we get our negative?
what is it?
At the
Bottom
bottom.
row. If you put a minus there, it isn't gonna work. And then you're gonna raise your hand, oh, mine's not working. You have to use a negative.
嗯
Plus 18 x squared. 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 18 x squ plus 12.
This was during my quiz too.
Okay, now we haven't talked a lot about this, but first of all, you should see something that looks like a parabola, but you don't see the whole parabola. Would you agree with that? This is what I see. I see like this, and then it disappears, something like this. Is that kind of what yours looks like?
A little bit.
Mine says error when I try to hit graph.
Okay. I don't know, I'll look at it. But
Because it was during it during.
I'm sorry about that. Okay. Now, I want you to look, this is not a very good picture, I don't like it very much, but it will help us answer question 1, or question A. Question A says, when will the ball hit the ground? I want you to think about this for a second. Isn't this when the ball hits the ground? This part of the problem down here doesn't really make sense because this would be like the ball kept going underground, right? This is where the y's are negative, and that would be where your height is negative. So I'm really not even concerned about this stuff. This is where the height is 0. This is where I'm hitting the ground. Remember, your points, x comma y, are time comma height. X is the time, y is the height. So this point right here is something comma 0. That's, the height is 0, it's on the ground. All right, now I'm gonna save you some more time. See this one over here? I don't care about him. Why not? Can somebody tell me why that point? I don't care
It's
about.
on the negative side.
It's on the negative side. Time, wouldn't this be negative something comma 0?
Yeah.
Can time
No,
be negative?
never.
No. So the only one we want is that one, and that makes sense. Because if I'm standing on the top of the building and I throw the ball up and it comes down, doesn't it only hit the ground once? Yeah. So that's the point I want. That's called a 0. You know how to find that. So second, first I got graph. Okay. Second, calc 0. You did this on your quiz, hopefully. I do not see a cursor, but I know where it is because my calculator tells me it's clear up here. I need it to be in here somewhere, so I'm gonna left it over. Sure enough, there it came. Press enter. And that ball hits the ground at 1.595 seconds. So your left bound is over here somewhere, your right bound is down here somewhere, and your guess is 1.595 seconds.
I have a question about my calculator. When on the graphing, it won't show me like
Oh, I got
that
this.
side, like the right side at all. It only shows me like more the left side.
Hit zoom 6. Okay, right, you guys with calculator issues, you need to come into office hours, okay? We have
got
to go
it.
through
Jig, where?
the material.
Now you do top part, bottom part, middle part. And then you do 1.5.
Okay, so question A, when does it hit the ground? The answer is 1.595 seconds. On a word problem, be sure you put a label on your answer. So when does it hit the ground? 1.595 seconds. All right, next question. B says, when will it be 15 feet above the ground? Now remember, this is the equation we are using. Okay, now, where do I put the 15? Remember what your variables stand for. X is time, y is height in this equation. 15, it says when will the ball be 15 feet above the ground? Is 15 a height or a time? It's a height. So it's gonna go in for y. So my equation's gonna be 15 equals negative 16t squared plus 18t plus 12. And if you don't like those t's, make them x's. Okay? Now, I'm gonna put this in my calculator, but what do I have to do first?
Equals 0.
Equals 0. So 0 equals negative 16t squared plus 18t minus 3.
Yes.
Okay, so new equation, got new numbers in it now. Well, they're all the same except that last one.
She subtracted the 5,
Lego.
so it can be
So
0 and
this
she'll
time,
get to the
when
other
I
side.
graphed it,
I mean 15. You move 15 so she can get a 0 on that
I
side.
got
Move it.
something that looks like this.
Nice.
Yeah. Why not?
Now, if we leave our picture like that, and I'm gonna talk about this in a minute, but if you leave your picture like that, totally fine, totally doable, but you're gonna have to be careful. Because to find this point right here, this guy right here, this would be left bound, right?
Yeah.
And this would be right bound. And these are really close together, so you're gonna have to squeeze that right bound in, okay? We can do it, we can do it. So second,
Up here. Right here.
and I got 0.203. So you're gonna have left bound over here,
Okay.
you're gonna have right bound up here at the top of the thing. And then you're gonna scooch it down just a little bit, take your guess, and it should be 0.203. Then you're gonna do the same thing for this one, but when you do this point, this will be your left bound, and your right bound will be down here. Second,
Where did it go? I did not do that.
and that one is 0.922. Remember this little rule of rounding. When you're rounding to the nearest thousandth, you look at that number right there. If it's 5 or more, you pop this up. That's how I got 0.922. When is the ball on the ground? At 0.203 seconds and 0.922 seconds. When, excuse me, not when it's on the ground. When is it 15 feet above the ground? Does that make sense? Here I am, standing on the building. I throw this ball up into the air. Does it make sense that there's 2 times it's 15 feet above the ground? Once on the way up, and once on the way down. Doesn't that make sense? All right, last question on this. How high is it after 1 second? Okay, so remember, this is your equation. So for part C, we're using the very same equation. How high is the ball after 1 second? Okay, remember your ordered pairs. X is time, Y is height.
So,
1 second is a time, so it's gonna go in right here. So we're just gonna put in 1. Oop, put in 1. I got 14 feet, but I did that in my head, might be wrong. Did you get 14 feet when you plugged in 1? After 1 second, the ball is 14 feet above the ground. Those are easy. Plug in T, plug in 1. All right, got one more problem to go.
Yay, let's do it.
Let's do it. Here we go. We're gonna start with our same basic equation, right there it is, starting with that one. First thing I have to do is make it fit my problem. So number 4 says, a rock is thrown from ground level with an initial velocity of 32 feet per second. So your job when you write your equation is put a number in there and put a number in there. Okay, so in this problem, I know it's gonna be negative 16t squared. All right, what goes in here?
32.
32. So that's gonna be 32t. Don't forget it took to a t. And then what's gonna go here?
0.
0. Why is it 0?
Because there's not another number.
Because it's at the ground.
It's on the ground. It's on the ground, so the initial height is 0, so I'm just gonna leave it blank. You can put plus 0 there, but it kind of complicates things, I'm just gonna leave it blank. This is my equation for all 3 parts of this problem. Okay? First question, when does the ball hit the ground? Now remember, every time you've done one of these problems, we have put a number in for y or x. Keeping in mind that x is time and y is height. If the ball is on the ground, what do we know? Its height is 0. So 0 equals this. The last one I put in my calculator. I think this one's gonna be faster to do it without the calculator
Okay.
because that factors.
Ooh.
Crazy.
So I'm gonna pull out a negative 16t, that's my GCF. Now, could you do this on your calculator? 100%. 100%. But when they factor, it's just faster to do it by factoring. So when is the ball on the ground? When t equals what? Certainly when t equals 2, but also when t equals 0. The ball is on the ground. Where are you going? No, we don't. Okay. The ball is on the ground at time 0, and the ball goes up and comes crashing back down at time 2. 2 seconds. Okay? So 2 seconds or 0 seconds. All right, next question. How high will the ball be 1/2 second. What do I do with that 1/2?
Plug it in
For, always plug it in, and what do I plug it in for?
for the T's.
For the t. So y equals negative 16 times 1/2 squared plus 32 times 1/2. 1/2 second. That's a t or an x. So you can type this in, as long as you type it in exactly the way I wrote it, you'll be safe.
A little trash.
I got 12 feet. I don't know if that's right or not. I got 12 feet. Again, you can use your calculator to help you with the arithmetic, no problem. And then last one. When will it be 20 feet high? So this is our equation. I gotta do something with the 20. Where does it go?
For the Y.
For the y, because that's a height. So 20 equals negative 16t squared plus 32t. Now I'm gonna put this in my calculator. Okay, but before I put it in my
Equal to
calculator,
0.
I gotta get it set equal to 0. Alright, when is it 20 feet high? Well, we're gonna find out.
Wrong number.
Anybody got that graph yet? This is what you're graphing right here. Type that in. I think I typed it in right.
No.
I got this. Anybody else get this? What does that mean? What?
No solution?
Okay, which means in this problem, can the time be negative?
No.
Can the height be negative?
No. Oh no.
Does that make any sense down there? No. Remember, you are looking for where you cross the x-axis, right? You don't cross the x-axis, which means
Actually.
this ball never gets 20 feet high. So when I stood out there and threw it up in the air with these spindly little weak arms, it didn't go up 20 feet, right? Okay, so the answer to the question is, when will it be 20 feet above the ground? Never.
Never.
Okay. P7 is due on Monday. If we didn't have time to do the extra practice, so if you don't get something, come into office hours on Monday
Oh, you'll
morning,
see me.
and we can look it over.